Okay, here's our example. We want to find the equation of the tangent plane to the surface. R of uv equals u times I plus v times j plus the square root of uv times k. And we want to find the equation of that tangent plane at the point 1, 1, 1. So what we're doing is finding the equation of the tangent plane to this parametric surface at this point 1, 1, 1. So how do we go about it? Well, the partial derivatives. The partial of this with respect to u, 1i plus 0j plus, oh my, that's uv to the 1/2. So I'll make that 1/2 of uv to the negative 1/2 times v. So in other words, this times k. All right, I'll let you study through that for a minute, but you should be okay with that. Partial of this with respect to v, 0i plus 1j plus, same story, only with the v in the numerator, with the u in the numerator instead of v times k. You know why that u is there? Because this is u times v, the derivative of u times v is u, and that's why it's here. That's why this one was v, same reason. The v is a constant, the u is the variable, so the derivative of the inside function would just be v. So now we need to set up to find our normal vector I, j, k across the top row, 1, 0, and v of the square root of 2uv, 0, 1, and u of the square root of 2uv. I think you know where I got all this from, right? From here for the second row, from here for the third row. And so evaluating all that 1, 1, 1, well, okay, we'll put in 1 here. V is 1, u is 1. Well, that's not so bad. That means this is a half. So is that. And so here is our normal vector to, it's not necessarily a unit normal vector, but any old normal vector will do when we want to find the equation of a plane. So there is the, by the way, that's I times 1/2, 0 minus a half, so negative a half I, minus j times a half minus 0, so minus a half j, and plus k times 1 minus 0, so plus k. So we can now write the equation of the plane as negative a half times x minus 1. Where did I get that 1? From here. From right there, right? Okay, minus a half, you know where I got the negative a half from here. Y minus 1, I got the 1 from there. And finally, 1 here also, so z minus 1, and that equals 0. Simplifying that, we get x plus y minus 2z equals 0, and wow! This is not so easy to achieve, but I've got a picture of the plane and the parametric surface together. By the way, to use my software to do that, this is the plane. If you take this equation and solve it for z, you'd get z equals x plus y over 2. Remember, the vector valued function that's generating our surface is r of uv equals ui plus vj plus square root of u times vk. So what did I do? I made this one, and this one, right? There they are. This is the parametric version of this. This is the vector valued version. But my graph won't graph it as a vector value function, but it'll graph it as a parametric surface. The parametric surface is the rainbow colored thing there, right? And at the point where, where x equals 1, y equals 1, and z equals 1, I might have to look down on it to figure out where that is. Down in here somewhere, we should see the plane, which is this black mesh that's tangent to the surface at the point 1, 1, 1. By the way, it looks like it's tangent to the surface all along that line right there, but I don't know the equation of the line. But oh, I guess I could probably find it if I worked really hard at it. I'm going to let it go at that. But isn't that cool? We can see the tangent plane and the surface at the same time. that might not be something you can do too easily with your TI-83s.